afternoon and good day to you all, and thank you for joining us for this fourth day of the Power and Mining Digital Dialogue series. My name is Claire Falkvane. I'm the head of content for NLIT Africa, and this series of digital dialogues is brought to you in collaboration with Mining Review Africa and ESI Africa. Over the course of the week, we've been exploring the world beyond the grid. And as mentioned previously, this doesn't necessarily mean off the grid, but it is more of an acknowledgement that there's a lot happening in terms of the provision of power that is outside of Eskom and grid-connected power. Over the last 3 days, we've discussed the general landscape for power and mining in South Africa in particular, and some of the options available in terms of self-generation, the need to do a thorough analysis of your landscape, utilizing things like data analytics, and yesterday, the role of storage. The focus on net zero is definitely one of the drivers for changing our energy landscape, but so too is the power crisis that we are experiencing in South Africa at the moment. So today, what we're going to be talking about is some alternative ways to minimize the impact of outages on equipment and just on your general operations. In addition, we're going to be talking about a rather ingenious way of utilizing what is considered to be unusable land. So do stick around to listen to all of that. So joining me to discuss this is Reshoketswe Zondi, a technology services manager with 20+ years experience and the chairperson of a Women in Mining chapter. She's joined by Gerrit Dortland, who is the Director, International Business Development for Watershed Geo. Thank you, Gerrit and Reshoketswe, for joining me today and for sharing your thoughts and your experiences with both of us.
Thank you.
I'm going to ask, I think perhaps what I should do, because Reshoketswe, I know that you have included some of your introductory comments in with your presentation, and perhaps it will be easier for us to do your introduction and presentation in one, and then we can do the same with Gerrit. So I'm going to ask Gerrit if you can do just a very short introduction in terms of who you are and what it is that you're going to be sharing with us today, and then we can go into your presentation, and then Reshoketswe will give you the opportunity to do the same.
Okay, so thank you very much, Claire. Pleasure for us to be on the Power Mining Digital Dialogue today. You're organizing, and together with Mining Review, AZ and NLIT, so welcome that opportunity. My background is in geosynthetics and in geotechnical applications for about the last 20 years. And since about 2.5 years, I'm working with the United States-based company Watershed Geo, that is in landfill capping and land repurposing, among others with solar technology. So glad to be on the show and happy to introduce our company and participate in this dialogue today. Thank you.
Thanks very much. I think if I could ask that we bring your presentation up, and as I said, let's run through what you have to share, and then we can give the, are we going to, it looks like we're going to be able to do your presentation. My technical team is so on top of things. They've already organized at Reshoketswe that you can actually do your introduction as well. So perhaps you could just do a brief introduction to who you are as well.
Good afternoon, everybody. I hope I'm audible. My name is Reshoketswe Zondi, but it's smoother to call me Shoki because my name is a tongue twister. I'm a mother in technology, and I'm a technologist for 24 years, and I've been in technology in different sectors, and currently I'm in the mining sector for 4 full years. My background literally is in technology. I've never worked outside technology. I only understand technology, and I feel and believe technology is actually the solution to a whole lot of things that we can eradicate in this world today. Thank you.
You would think after 2.5 years of us doing this that we would know when to turn our mute buttons on and off. But what I was saying is that is a very powerful statement, and I am looking forward to hearing how that's going to happen. But I'm going to hand over to Gerrit to talk about what it is that he was alluding to in terms of the work that he's been doing with Watershed Geo. And I have found this technology really absolutely fascinating, and I hope that all of you will too. So, Gerrit, I'm going to hand over to you. I think Reshoketswe and I are going to take a bit of a back seat and let you do your thing.
Thank you. As we were preparing this presentation today, Claire asked me to give a bit of an introduction presentation on the matter that Watershed Geo is working on. Watershed Geo, as I mentioned in my introduction, is a US-based company in Georgia that has developed a technology for capping landfills, and they've been doing so over the past 15 years. The company was founded by managers and operators of municipal waste landfilling, and they ran into typical challenges with erosion control, dirty or contaminated runoff water, instability at slopes, and heavy footprint for carrying borrow soils to sites. And so they thought about a different solution for that application, and they came up with Closure Turf, which is a engineered synthetic based turf for a lightweight turf for capping landfills. And although I did not see this as the first slide in my proposed presentation, this is an interesting site that we're showing. This is actually the turf being installed a couple of months ago. It's a little bit further ahead in the project now in Ghana, where we have a closure project ongoing and a second one in preparation for a municipal landfill together with a company in the waste area called Zoom Lion. And it's about 14 hectares on this side, and I think equally on another side. So next slide, please. Not only we work in the municipal waste sector, municipal waste landfilling sector, but we've quickly entered into tailings and ashes and industrial residues of different kinds. So this is an example of the Mississippi phosphates site that was actually having a trouble. The company that ran that site was creating fertilizers and got out of business, so it became a state liability, and the Environmental Protection Agency, after some evaluation period, selected Closure Turf to be placed on that site. And the reason being is that each rainfall event, millions of gallons of contaminated water would flow into the stormwater ponds, but also into the adjacent ocean grounds, which were used for fishery. So they had an imminent direct challenge to cover, and they selected Closure Turf not only because of the need for closing that particular site, but in particular because it went fast, months instead of years. It led to clean water runoff, and it led to a huge cost saving in cleanance of water. So no dirt water coming from that site, or potentially contaminated water, but clean water, saving hundreds of thousands of dollars each rain event. And in the construction of this site, also about for this first 120 acres, which was phase one, about 139,000 truckloads of borrow soil were avoided to go through the city. So it contributed to the ESG perspective, and about $6 million in construction. So a lot of good happening on that particular site. So if you would move to the next slide, please. So beyond industrial like phosphate, also in coal combustion residue, which is the residue of thermal power plants, there's a lot of need for those to be covered, and we're as a company working with many of the thermal power plants in the US, and this one was in southern USA, and it was covered also because there was a potential hazard of contaminated water flowing into the nearby river. But by adding closure turf, it was contained in the right way. And in those conversations with the utility, with the thermal power plants, they were asking us, what can we do with the impaired land? What can we do with the lost land? And our company then came up with several solutions, one of them being the solar power cap solution that we're discussing today, that is helping also off-site industries or locations to generate their renewable energy. Next slide, please. So what is power cap? Actually, you've seen the engineered turf being placed on a couple of sites just in the previous few slides. When developing power cap, there was one of a couple of main criteria, being that it should not harm to the underneath laying closure turf or impermeable layers that were covering the waste residue site or the landfill. So what we're looking at here is in the left lower picture, which you're looking at, is the back side of a friction strip, that is built up with studs and turned upside down. This is the central picture on the lower side of this slide. This friction strip is anchored into the blades of the artificial turf and the sand that is filled into the artificial turf. This is a thin layer of sand, but still enough to keep the studs of these strips. And with those two combined, there is a system that is lightweight, not doing any harm to the underlying impermeable layers, that is also posing very little footprint to the area. So actually, that's the base of this invention for this type of covered land. Goes uniquely into cooperation with closure turf. So if you would turn to the next slide, please. So these are a few installation details. As you can see, these rails and these strips are laid and placed on the closure turf, where these studs are here in these pictures anchoring into the grass blades, but effectively with the panels, they will go further into the sand and anchor themselves, so that a very solid connection in between the studs and the mounting structure is being created. The panels will also be flexible to follow the geometry of a site to some certain extent. So if you have slopes or if you have some settlement in your site, there is flexibility in the system. If the settlement or the geometry variation would be too much, there would be repair methods or ways how you can easily fill up voids, for instance, underneath these areas, and still have the right geometry for the panels to be placed. They can also be mounted and demounted flexibly, so after use, it's not as with concrete or steel structures that you have to remove those and have another impact on your footprint, but it's quite easy to remove. In some dedicated cases, there's ballast being added, for instance, in highly wind exposed areas or in very steep slopes. And we have different methods. Here's one method with concrete ballasting, but there's metal ballasting and other ways how we're doing this at present as well. And only in very few cases that it's needed. Generally, the system is robust enough and resist wind uplift pressure in the right way to not move anywhere. So next slide, please. So extensive testing being done both in practice and in lab, both on closure turf and power cap, first in the United States, which led to full approval of the system and also been verified by Independent Engineering for Europe. So with our first, maybe if we move to the next slide, we'll see that. With our first pilot and demonstration projects being out since 4 or 5 years now in the US, and actually installing in Germany under approved engineering design. We're scaling up and we're getting into larger projects. So the system itself has been applied and has been working in practice and in laboratory and in practice under several hurricanes. And now we're actually in discussion and working with landfill owners, but also with utilities to scale up and make them really self-standing energy providing units, and particularly with utilities or with communities that are being close to a grid. This energy can be used into the grid, or if it would be in an industrial or mining operation, it could be used on site. So if we move to the next slide, I think that would also be my last slide. Yes, this is a company we've been working with over the past few years, Tennessee Valley Authority in the US. Several sites for them with recovering with closure turf, and only a fortnight ago they gave the green light internally to equip one of their sites in between bracket as a pilot, but it's going to be a large plant of about 100 megawatt, which is going to be installed with solar. So we're all very encouraged and happy that larger companies have decided that this is an effective footprint saving way that allows for reutilization of otherwise wasteland, turning that liability into an asset. So as a short introduction, thank you for that opportunity. I don't think there's any other slides, but maybe the last one here. Thank you very much, Claire, and turning it back to you.
Thanks so much, Gerrit. I am actually going to, I think once Reshoketswe has done her introductory bit, I am actually going to ask if you could perhaps just give us some idea of why reuse of some of that land is so important. I know that you have some slides that illustrate that, but it is actually a very nice way of us also kind of getting into some of the fundamentals. So what I'm going to do is ask Reshoketswe if you could share your information with us, and then we can start doing a little bit of a deep dive into some of the details. Reshoketswe, are you still with us?
Yes, I am.
Okay, cool.
I actually have questions for Gerrit. I actually want him to work with the mining sector to actually, when they're doing their mining closures, to actually come and support and actually offer this solution. I'm very excited about his presentation, and it actually is.
I told you.
It's very, very important within the mining sector to actually have sealed land that is very safe and that can be used to power communities around. So I'm very excited, Gerrit.
Yeah,
thank you,
it
Smokey.
just seems like such an obvious solution, and so it's fantastic. But you know what? I know you have some really great information to share as well. So we're going to hand over to you, and then we can get this party going.
I've already touched a bit on myself, and thank you for the opportunity to actually invite me to share some highlights of technology and how it can actually save some of the issues that the world is actually facing. This is just a summary of my career over the 24 years. Started as a GIT, moved into management all the way from 2006. I've worked in the banking sector, I've worked in the pharmaceuticals, I've worked in purely IT companies, and currently I'm in the mining sector. Next slide, please. Basically, I fell in love with technology all the way from school. So I was privileged to have parents that actually sent me to one of the best schools, and that's where I studied technology. So technology is part of my blood, is in my DNA, and literally I've been in technology way before matric. Next slide, please. This is just a picture to show part of history. I am that old. My first Pentium back in varsity looked exactly like this, and I know for the young ones, it's funny because we had a floppy disk that was literally carrying 256 meg, and right now children are talking about terabytes and gigabytes and all sorts of things. Next slide, please. Now we get to the crust of why we are here today. So I'm going to take you through the technology importance and how it can actually save mining and improve efficiency and effectiveness of a mining operations through digitization. So with me, I wish everything was an app. I don't believe in writing on paper. I don't believe carrying around files and all the mandate things that we do. If anything, I wish the world could go back to how COVID started. I'm not belittling the lives that were lost within COVID, but if we could appreciate how COVID shook the world and we literally all had to adapt. It didn't give us an opportunity to think about it or pause. We literally had to adapt and found new ways of doing things. For instance, children were now learning schools through online. We are no longer able to go to school. It was the same within the mining industry. The people that were used to just doing manual work and manual labor, their new normal now was to have video calls with their teammates and so forth. So I would literally challenge the world, and let's look at the learnings and the positive out of how COVID shook us and then take it from there. Next. I think we're experiencing technical difficulties. I'll just talk through my presentation while the technical team gets us to the next slide. Basically, how you can optimize your operations is through technology solutions like big data. I'm going to take you through what big data means, and I'm going to simplify technology for everybody. I know technology people like to think they are smart and they use big words and confuse everyone, but I'm going to simplify it for you. Big data literally means exactly that. It's data that is huge. And if you break it down, you've got volume, which is your size of your data. You've got variety, how you receive that data. It could be structured, it could be unstructured, it could be all sorts of the above. And then we are talking about velocity, literally the real time and how you want to stream and access that data. Basically, that is what big data is simplified. So if you think of volume, you think of variety, and you think of velocity and how you can use that big data. Next slide, please. Now we come to the interesting things. Within the industry, mining industry, we know that we are still facing harassment, we are facing safety issues, we are facing failed technology. For instance, we've had in the news in the past few months where people were crushed with an elevator that went into the mine, deep into the mine. And we are going now to discuss how the Internet of Things can actually help eradicate some of these issues. So basically, simplifying things again, Internet of Things, it's a group of devices that are connected via a network in order to perform one function. I'll break it down more. So let's say you are in the mining sector and then you work underground as a female. One of the things that females face is security. Some women are sexually harassed, some women are abused. A whole lot of things happen underground that you're not privy of when you are working in a corporate office. So we've got a solution where we can offer people with a helmet, and within that helmet, I'll just speak about 3 things that can save lives. You've got a GPS coordination that will help you realize where that person is, and then you've got a smoke detector at the back of that helmet where it can actually save life and let you know that there is fire, and alert people to be able to leave the mine on time so that we don't lose lives. Because we know in the mining industry, if somebody dies or passes away in a mine, the regulator closes and shuts down the mine, and then the mine has to go through investigations before the mine can be reopened. So this helmet can literally, if we just take 3 of those things, can literally save lives. For the person that is afraid of somebody that is harassing them, they don't have to carry a secret video recorder for them to know and report that I have been harassed by so and so. The GPS coordinator on both their helmets will be sending those reports to a server, and then that information can be used for creating a grievance if that person feels that they want to create a grievance. The body temperature and the SOS light on the helmet can actually dispatch the ambulance and the people that are able to come and save you in case there's something wrong when you faint and you're underground and you cannot help yourself. As well as, like I mentioned, the smoke detector can actually help save lives and get you out of danger when you underground and then you're not able to see the fire before it's too late. So if you combine your IoT, your Internet of Things, and big data, and you build a little bit layer of artificial intelligence, you can actually improve your safety awareness in the mine. And this also goes back to the cost and productivity can be optimized. So again, the mine will be able to run cost effective, and it will enhance the safety protocols of the mine and its employees, as well as meet your business requirements for your mining house to actually substantiate and stay longer in business. Next slide, please. Like I said, I mentioned underground. So I hope that everybody gets the link at the end of this webinar. You can play the YouTube link later on, where it simulates how the systems that we've implemented or installed in the machinery that goes underground that can actually shut itself down when I, for instance, Shoki is walking around the mine and I'm ignoring all the warnings on my helmet, and I'm ignoring my lamp that is alerting me to say there is a TMM that's approaching you, you are going to be injured, or it could crash you and then it could kill you. The mechanisms that are put on those TMSs have an artificial intelligence. They literally shut down the motor, so it will shut down the TMM, and then even the driver of the TMM will not be able to override it. So this is where technology literally will save a life, and nobody will lose your life, because I will not be able to be in harm's way, and that car that's underground will actually not be able to function. It will just cut the engine, and then we are both saved. Nobody will lose their lives. Next slide, please. I spoke about also the big data earlier on. There's a product manufactured by Microsoft. It's called Power BI. This is mainly for your GMs, your VPs, your deciding ExCo members. They can literally sit in a meeting and zoom into data. For instance, if you want to know your costs of your material for the past 12 months. You don't have to wait for somebody to send you a report. With Power BI, you can literally filter live and real-time data and zoom in within the Power BI solution to be able to enable the ExCo members or any manager deciding people to make decisions on the spot. So you can save costs, you can literally, there's no paper that is based on the solution. Everything is online, it is secure, so it is a very secure protocol. It sits on the cloud, and within that cloud, you do have authentication mechanisms that have been put. So Shoki cannot go and access information that I'm not privy of or I'm not given access to. So it is efficient, it is proactive, and it's also used for repetitive tasks. If we know on every month we sit and we make decisions on the price of our commodities, we don't literally have to sit around and wait for manual reports to flow in and sorts of things. We literally can just use one Power BI solution and filter through the data within the organization and be able to make decisions and grow profits and revenue within the mining operation. Next slide, please. So I know that sometimes technology makes other people uncomfortable, and some people have the negative towards technology, to say technology is replacing people and so forth, machines are replacing people. And I say no, because even the machines that are doing the mandate jobs that used to be done by people are being manufactured by people. So basically we need to reskill or unlearn a skill that we have, and then stop being comfortable in what we have right now and reskill ourselves, because these machines are not making other machines. You still need humans to build the robots. You still need humans to actually manufacture and produce the technology advances that we are using. So you still need engineers, you still need technologists. And if we can come out of our comfort zones and see the advantages that outweigh the disadvantages, we will be able to embrace technology in its true form. And to be quite honest, I'm the proud mother of many children, and my purpose in life is to strive to bring technology to all of the people on earth while I still have time on earth. And my slogan is literally touching one life, one soul, one day at a time, and challenging life with through strategic partnerships that we forge, be it personal or business, and literally making sure that you are efficient and effective in all that you do. And thank you so much. My name is Reshoketswe Zondi, and I'm a proud technologist for 24 years and counting. Thank you.
Reshoketswe, thank you so much. I think it's particularly important for mines and for people operating in the sector to really pay attention to some of the benefits and the opportunities that big data and data analytics can bring. And we touched on that the other day, just in terms of the need for very detailed business and data-driven decision making, because I think that once you have clarity on where certain things within your organization are perhaps not optimally optimized, I don't even know if that's a word, there is definitely there's a way for you to just improve how you are doing things anyway. Gerrit, I'm going to ask my team to pull up some of the other slides that you shared with us, and specifically ask if you could just talk to us about beneficial reuse of land, some of the traditional solutions that have been used, and then perhaps the specifics of the closure turf solution.
Sure.
So, Chanel, could I ask you to bring that up? Thank you.
So I think here we're seeing we're looking at two closures. One, a regular closure in the way that we find regular with closure turf, and one where a power cap's been installed. Actually, if we look at landfills in a traditional way, or tailings in a traditional way, ashes from coal combustion industry, you would see that there is a traditional way of bringing lots of borrow soils to that site, then capping it and containing it. So it's an after use liability. And where we came in with closure turf, we thought that a lot of that eventually footprint raising installation was let's say resolved. besides of all the, let's say, functional advantages that I spoke about with clean runoff water, less erosion problems, instability, lightweight, so saving space also to add additional municipal waste or industrial residue. But as I just mentioned in the presentation, we just got into contact with those owners of those landfills, and they really were looking at ways how they could better utilize their property, their responsibilities and liabilities. And we've looked at recreational areas. We've even turned a former waste area into a wakeboard facility for leisure and for fun, or for sort of sidewalks on a park. But the vast majority of the request was, okay, how can we beneficially use this material or this area to generate energy? And that's how we came to using solar and developing that for this type of activity. And as landfills, in the picture here, you see a covered landfill or industrial area. That's often close to a populated area or to a site that needs energy. But above and beyond, there is also need for good infrastructure to that site. And on these locations, there often is already an infrastructure in place that you can use. And that goes from simple things as access ways and fencing and availability of water, but it can also be that a grid connection or a transformer or a station that generates the power is already close to that site. And that's a big advantage. So you only need to do a fraction of the investment that you would need to do as you were creating a full new energy plant, so to say. So you can use existing facilities, and in the case, just to give the example of thermal power plants that are going through transition at the moment, and worldwide they are, but certainly in the US and certainly in Europe, I can speak for. We see that they're trying to get their energy balance much more towards renewables and less fossil type of energy generating sources. So they're working to get this mix better, and they have, like at their utilities already, the infrastructure, the generators, the grid connection, so optimally located close to where the energy can be used. Well, these are a few of the examples. I could talk about fulfilling ESG compliance and goals that companies have. First of all, by generating renewables, but also by not occupying, let's say, other land for their activity, but using this type of land, and saving on the green field, and also not having to have municipalities, for instance, that are nearby being overloaded with passing vehicles, for instance, to bring borrow soils to site. So many of these are all part of beneficial reuse, and depending on the situation and the infrastructure, there can be different beneficial reuse purposes that play a big role for utilizing these. Oh, thank you. That's this would be a way how a traditional cover is being made and how a traditional system would work on landfill. So you have an underlaying waste body, could be industrial waste, could be coal, and then there's a topsoil. And instead of our system, as I explained it, there would be steel frames and concrete blocks, and those would then be connected to inverters, transformers, and to the grid. So what we do with our system is that we have a lightweight system, and we replace those concrete blocks and those steel structures just by flexible friction strips and rails that hold to the panels and then feed into the grid as described. I don't know how many slides there are, so I can talk through, but I hope that that helps. This would be a typical top deck installation for a site where you would not utilize the slopes. And it's just given as an example of how concrete and steel structures are used and how we replace them by our power cap technology that does not use this steel structures and concrete footing. So I don't know if there's other slides that I can speak to, but else is there a next slide here? Okay. Yeah, just to finish there is these are typical problems that you would meet if you are installing PV plants in a traditional way on waste facilities. So these are not built with strong vegetation soil, so you would get soil erosion. In some areas with a lot of precipitation, you would get overgrowth of vegetation. And anyway, to place traditional solar into place, you need those heavy concrete blocks and steel structures, which you have to mount. And after the lifetime of the PV project, you also have to demount them. So you're impacting with a large footprint twice. Next slide, if there is one. So this is then the, and some who not have catched up since the beginning, this is just explaining the way how a traditional closure is being done and how is one done with closure turf. In a traditional way, you would have a waste body or a tailings or an ash pond. There would be a leveling layer just to avoid that the sharp objects are pointing through. Then there would be a sealant layer that avoids influx or leachate, let's say, from this pond or this tailings to flow into the environment, to leach out into the environment. And in a traditional way, as you can see in the left cross section here, that's the screen, there is a topsoil layer that requires borrow soils to be brought to site. And then there is a vegetative layer where, as with closure turf, there would also be this waste body of tailings or ash or municipal waste. Then there would be a leveling layer. And on top of that leveling layer, there would be a sealant. And instead of the 1 meter of soil and vegetative layer, there is this engineered synthetic turf layer. So lightweight and saving all of those borrow soils. Next slide, if there's any. This is showing the elements of the system. So there is the impermeable membrane, there's an engineered turf, and then there is a specified sand infill. And that elements are, particularly the sand infill, are sourced from as much as possible local sources. Like with the PV system, with the power cap, we are not bringing panels from the US, but we're of course trying to use as much as possible local sources that we can. Next slide, please. So as the intro already giving the insight, here is the two combined. This is the synthetic artificial grass layer, and then on top of that artificial grass layer, the power cap system that really anchors into the blades, into the artificial grass and the underlaying sand layer. So it just depicts very schematically how this system is built up. Next one, if any. Okay. I sort of have an idea I'm giving two presentations, but appreciate it, Claire.
Yeah, no.
I take too much time speaking.
You know what? I think it was really interesting to be able to see how these two elements fit together. And I'm assuming that the really important part is that membrane, that is really the kind of key technology to helping to prevent the erosion, the leakage, or is it really the combination of all three?
Yeah, it is the combination. The membrane is a vital part avoiding, let's say, new water influx into the waste body, and by the water that would then leach out from the waste body would potentially be contaminated and hazardous. Also depending on the nature of the waste or the industrial residue that's being contained. But the membrane needs to be protected for UV, for water flow, for many purposes. So the closure turf, the turf layer with the sand infill, they keep the membrane in place, they keep the turf in place. So it's a lightweight, but it's an engineered construction that really keeps itself into position, and therewith also has this prolonged engineered lifetime of over 100 years. So we have done all testing on that, all that elements.
And this is not a solution that you've just kind of proposed as suitable for mines or landfills. I mean, you were mentioning that you've actually done work with power utilities as well to utilize some of the ash piles and stuff like that. Are you able to talk about some of the work that you've done there?
Yeah, absolutely. Originating from the municipal waste industry for communities, but quickly there was an interest from industrial sites such as utilities, power plant utilities, and also have done some work for mining actually in the US, not with power cap, but with closure turf for acid rock type of covers. And it was before I joined the company, so I only know these names of Rio Tinto and companies we've done some work with directly or through our partners. But yes, for the utilities, it's a serious market, and as I just mentioned, them being so close to the grid and already having the infrastructure in place that they can use it, and having the liability for the lignite or coal ashes which they generate, like mining operations have a liability for the tailings that they have, and they could either try to recycle them, reuse them in the long term, but if they have a contaminating element to them, they have to contain them in a way, and yeah, that's where we tech into and try to utilize our technology.
Fantastic. Reshoketswe, I wanted to, if I could shift the attention back onto you just for a moment. When we have spoken previously, you've mentioned that in your current job, you have also been very actively encouraging the use of large-scale UPSs within operations. And I was wondering if you could explain some of the thinking behind that. I mean, you know, the data and the IoT stuff is obviously vital to supporting efficient operations, but this is something that you've put in place specifically to address some of the current load shedding challenges that we're experiencing.
Okay, so basically within the mining industry, a mining operation is a 24/7 operation. So it's not a start and stop. So we know that power is not stable in South Africa. That's a given. In order for your operation to be optimally effective, you literally have to have a UPS, uninterrupted power supply, that when Eskom decides to take their power off, you have a UPS that takes the weight of, or that takes over without your systems being shut down. Because you've got very expensive systems that are in the manufacturing plant of the mine. So you cannot afford millions and millions of infrastructure to be on and off like a kettle. So you put your UPS in part of your data center, so that when Eskom takes out their power, your UPS takes over, and then after your UPS, it's either you put your solar, which is similar to what Gerrit has explained, how you put your solar. So your solar won't be to the grid, it will be directly to your data center. Or you could have a generator. So you've got those two power sources. Meanwhile, Eskom decides when to give you power back. So you'll have a massive generator that can run for instance, 24 hours. When you don't have power, or you can power by solar, similarly to what Gerrit has given us earlier on. So your operation can be fully optimized and running beyond Eskom's load shedding. So you're not affected by load shedding. Your business is as business as usual, whether lights are on or off at Eskom. So that's how the mining industry actually appreciates or uses power beyond the grid. And it's cheaper, you don't have to pay.
Sorry, please continue.
No, I was just saying it's cheaper, you don't have to pay Eskom. You have got your own power, solar or generator. So it works out for your bills as well.
Yeah. You know, I realize that obviously within mines, there is a lot of very sensitive equipment that is impacted by fluctuations in power and stuff like that. And since the implementation of these UPSs, have you seen perhaps a reduction in the downtime or the recalibration, or just the number of faults, if I could put it that way, that are being experienced in your systems?
There's no downtime. UPS means uninterrupted. So you don't even feel that there's load shedding. You're the only one who's forever up and running. Literally, your UPS is that saver between your switching between power sources, Eskom and whatever else you've put in the back end. There's nothing. So there's zero risk to your infrastructure. That means your millions are safe. Your infrastructure is safe. Moreover, your data is secure because you're also running a data intensive mining operation. You cannot afford to be having data corruption because Eskom is taking their power out. So literally you also have, and remember with your data that is corrupt, it's also your repetition. You cannot have your data, for instance, being restored all the time because you've lost files because Eskom. So yeah.
Yeah, that of course is a big concern, because it's one, sometimes you lose things and it's almost impossible to get them back.
So fortunate with technology, we do have automated backup for our data, our systems. So that means you schedule, depending on how much data you are running within your operation, you've got scheduled backups. So that means you can never lose your data. So you've got scheduled backups every night for certain systems that are run. So also it depends on what you have. The moment you have the 5-star that you can put in, where you can literally write data to data, I mean disk to disk, sorry, instead of using old technology like tape that is not reliable. So you literally can have a hybrid where one node could be writing to another node and it's backing up overnight, and then you literally, when something happens on your infrastructure, you can just switch to node 2 without ever the business losing connectivity, and they can even feel it while you sort out your node 1. So that's what technology can do.
That seamless interconnection, that, you know, even if your UPS is just bearing that load for a short period of time until the generators kick in, it's that seamless integration that I think is the most important. Gerrit, there's a couple of questions that have come through here, and I just wanted, I'm going to give you just sort of like 3 or 4 minutes, if I may, to answer some of them. And it says here, so is there any kind of landfill or tailing space that you cannot close with turf? And if so, what would you do?
Yeah, great question. Actually, we're talking about landfills and ash stacks, and we extend to ash ponds or tailing ponds, and that generally describes the difference between lower or higher bearing capacity soils. So if a tailings is created more as a pond having a very high content of water, that means that the load bearing capacity of these tailings will be less, and there will be geotechnical matters necessary to form the good base for such a pond. Now, saying that, for capping such a pond, saying that, we have a very lightweight system. So instead of having to have a load bearing capacity to bear the 1 meter of soil or more, we just have to bear a thin layer that's consisting literally of a couple of centimeters, if not less. And because it's such light, it's really not a problem of the system, which would be, you know, minimal bearing capacity would already be sufficient to place the power cap and the closure turf. But during construction phase and during maintenance, you need to access, particularly if these are larger stacks, larger areas. So you always will do a geotechnical survey towards the load bearing capacity of those soils. So to answer your question short, there is, or the answer of the one that posed it, there's very limited, it's very little limit, it's very lightweight. So, but there's always a geotechnical survey that proves whether any particular measure is necessary or whether it will go as it is.
And then one of the questions as well that's come through, which I think, ironically enough, it came through as I was asking you the question about the work that you've been doing with utilities. And that was whether you've been approached to investigate how to use this in the repurposing of coal-fired power plants. Now, as you know, in South Africa, we are going through a big repurposing exercise, and I'm assuming that this was fed partly by that kind of thought process. So, is this something that would be applicable as we start repurposing some of our existing coal-fired plants?
I would say absolutely. I see it in the US. I mean, we work with the majority of the utilities which were previously, or which are still partly coal-fired nowadays, and we're capping their ash ponds as it's obligatory and requested, and they want to do it from ESG purpose, but also for repurposing of the land. And I'm seeing it in Europe, and I do not expect it to be different anywhere else. So I would certainly see an opportunity if there is power plants in transition in the US that want to reutilize or want to contain in an environmentally good way their ponds and reutilize them. Absolutely, I mean that's what we aim for here. We've been like 12 years in the US only, and now at a point that we see that internationalization is logic, and we're doing it. So we're definitely welcome those opportunities.
We have time just literally for some last thoughts. So Reshoketswe, I'm going to ask you just with the overriding thought that you would like the audience to take away with them today.
Can I answer question 4, which was about mining being proactive?
Sure.
Yeah, thank you for that question. For proper running mining houses, they do follow legislation, and they take it very seriously when they need to have mine closures. So they start planning. For instance, if they know that the life of a mine is left with 15 years, they start putting actions in place in order to mitigate and how they're going to close off that mine properly. For instance, using solutions like Gerrit has mentioned, where they close off the landfills and cover them properly. But if you've got dodgy mining houses, these are the ones that run away and say it's not my problem. But for proper registered mining houses, they actually have proper closure plans way ahead. For instance, like I said, 15 years before they can actually close off the mine, they start implementing certain closure mechanisms. By the time they close off the mine, it is safe, it is secured, and proper turfs, for instance, have been put in place, and they don't leave the mine or the land or the community that they mined around in a worse situation than before. Just to answer that question.
Fantastic. Thank you so much. I think that's a very important point. And just as I said, any last thoughts that you have that you would like the audience to take away with them?
Let's embrace technology. I think one thing we have in common with Gerrit today is the use of technology in order to solve and eradicate certain issues that the world is facing. So if we could collaborate around technology solutions that are actually existing, or even investigate newer ones, we could be a better world to live in. It's not the enemy. Like technology is not the enemy, guys.
Yeah, no, I like that a lot. And Gerrit, I will leave the last word up to you.
Thank you so much. And Shoki, I much underline what you're saying. And with the technologies and the IT and the platforms which you're featuring but I think also beyond Africa, I think those are really great steps, and taking us forward and bringing new opportunity also for labor. So much buy into that, and absolutely agree that technologies as we have for beneficial reuse should not be limited to one area, but should be implemented where they can be implemented to mutual benefit. So thank you very much for the opportunity.
Thank you to both Reshoketswe and Gerrit for joining us today, for sharing their incredible insights with us. Ladies and gentlemen, thank you so much for joining us. Tomorrow is the last in our week of digital dialogues in the power and mining sector, and we are going to be doing a project post-mortem. So join us as we unpack how a project would run from start to finish, things to look out for, things not to look out for, yeah, just a great way, I think, to close off this week. So from myself, Reshoketswe, and Gerrit, thank you so much for joining us. Have a wonderful day further, and we'll see you tomorrow. Take care.